Hello everyone, our topic of discussion is privacy risk associated with internet connected sensors used daily at our homes. Let us begin by understanding what IoT sensors actually are. IoT or Internet of Things refers to the interconnection of computing devices to the internet and to each other but are not typically considered as computers. These devices include appliances, vehicles, and other everyday objects. What sets them apart is that they have sensors built into them, allowing them to collect and share data, often without human intervention, in order to make our lives more convenient, efficient, and informed. Sensors play a major role in IoT systems. They are devices that detect and measure physical properties or environmental conditions such as temperature, motion, light levels, and humidity. They play a crucial role in IoT devices by providing the necessary data for them to function effectively. Let's take a look at some common IoT sensors found in homes and offices. Security systems, lighting controls, and automated doors use motion detectors to detect movement. Thermostats control temperature and humidity levels in room. Smart bulbs work using light sensors to adjust lighting and to save energy. HVAC systems use occupancy sensors to detect if a room is occupied, allowing for efficient control of the room's environment. To ensure safety by monitoring for potential hazards, that is smoke from fire and presence of carbon monoxide gas, smoke and carbon monoxide detectors are used. Now that we understand what our sensors are, let's explore how they track us and collect data. Motion sensors detect movement by measuring changes in infrared light levels caused by body heat. This allows them to detect motion without identifying individuals. Temperature and humidity sensors are thermistors, which are materials that change resistance with temperature. This resistance value is converted into a digital temperature reading to measure presence, occupancy time, etc. This can be used to detect occupancy of rooms. Door and window sensors use simple on or off switches to detect if a door or window is open or closed. When the magnetic field is broken as the door opens, it sends a signal. These are used in entry or exits from buildings and rooms. Light sensors, on the other hand, use light dependent resistors or photodiodes to sense light levels. As light intensity changes, the sensor's electrical resistance or conductivity changes accordingly. Image sensors are electronic devices that capture digital images, and they do so primarily through two common components: CMOS, complementary metal oxide semiconductor, and CCD, charge coupled devices chips. These sensors are used in various devices such as digital cameras, smartphones, and security cameras to record visual information. Moreover, it is used in facial recognition, which can be the easiest way of identification. Now, let us discuss whether IoT sensors tracking is privacy preserving. By default, most consumer IoT devices and platforms are not strongly privacy preserving for a few key reasons. Firstly, data is frequently transmitted to a company server in the form that can be traced back to individuals. Secondly, broad data sharing with third parties is often permitted by default in privacy policies. Thirdly, users are typically granted limited control over data collection, usage, and opt out mechanisms. Lastly, the absence of robust security measures like encryption, access controls, and updates exposes data to potential unauthorized access. Nonetheless, with the implementation of appropriate precautions and user controls, it is possible to enhance privacy within the IoT ecosystem. Now that we know how sensors collect data, let's discuss how this data can be cleverly correlated to profile users and unveil insights into an individual's personal details, specifically in home. This process, often referred to as data profiling or data fusion, involves combining multiple data sources to draw conclusions about an individual's behavior, preferences, and habits. Let's elaborate now on the implication of data fusion from other sensors. Motion patterns over time inside a home can indicate when occupants typically wake up, sleep, work, or entertain guests. Combining door and window events with camera footage outside a home could expose daily routines and identify visitors. Matching temperature changes to calendar entries can infer if someone is on vacation based on the thermostat habits. Light and motion metadata collected via multiple IoT devices, when integrated with public profiles, can reveal occupants' identities and relationships. Historical energy and appliance usage tied to a location through smart meters can expose personal consumption behaviors. Aggregating IoT, mobile, and online activity data allows advertisers and data brokers.
Potential for company tracking. Even in the presence of privacy features, the ability of companies to track users persists through various methods. Device and account identifiers, often unique to individuals, can link multiple sensors and annual usage patterns over time. The inference of identities become possible through metadata such as locations, behaviors, and connections to other profiles, allowing companies to create detailed user portraits. Furthermore, when sensor data is associated with public records, purchases, or other external data sources, it amplifies tracking capabilities, providing insights into a user's broader life context. The risk intensifies when unencrypted traffic analysis and device fingerprinting techniques are employed by companies and third parties, enabling the tracking of user activities across the digital landscape. Now, let's go to the next slide, privacy implications. Now that we understand how sensor data can profile users, let's discuss the privacy implications of this technology, particularly in long-term data collection. Beyond the surface, sensor data can intricately reveal personal details, unveiling details that isolated or short-term data points can't provide. Remarkably, long-term sensor data can mirror major life events like home renovations or shifts in family dynamics, offering a window into deeply personal matters. Gradual changes in usage patterns over time might expose not only lifestyle preferences but also sensitive health issues, chronic conditions, or disabilities. Metadata that records who shares space and their activities can uncover personal relationships, social circles, and support networks. Even absence periods from home, when combined with mobile tracking, can meticulously track vacations, business trips, and travel habits over many years. Moreover, changes in device usage, home security patterns, and energy consumption over the long haul may correlate with significant financial events, leaving individuals vulnerable to unwarranted scrutiny. Now, let's discuss potential privacy risk of long-term IoT. The potential misuses of highly sensitive long-term IoT data include stalking, surveillance, insurance, and credit score manipulations, targeted scams, and phishing, discrimination by employers and landlords, diverging private medical conditions, political and ideological profiling, and unwanted marketing and ads. To curb these potential harms, strong privacy regulations and user consent are needed to ensure appropriate access and usage of long-term data collection. Now, let's discuss case study. Recent incidents in the IoT landscape have highlighted vulnerabilities and lapses in security, putting user data, privacy, and physical scrutiny at risk. The most famous Mirai botnet attack happened back in October of 2016, was the largest DDoS attack ever was launched on service provider Divine using an IoT botnet. This led to huge portions of the internet going down, including Twitter, The Guardian, Netflix, Reddit, and CNN. This IoT botnet was made possible by malware called Mirai. Once infected with Mirai, computers continually search the internet for vulnerable IoT devices and then use known default usernames and passwords to log in, infecting them with malware. These devices were things like digital cameras and home appliances. Orvivo's exposure of 2 billion logs, including sensitive information like passwords and geolocation without any access control, underscores the gravity of this issue. Similarly, Verkada's mishandling of 150,000 surveillance camera feeds made publicly accessible raised privacy concerns. Furthermore, a troubling statistic reveals that 25% of IoT devices suffer from insecure default passwords, leaving smartphones susceptible to unauthorized access. Even seemingly innocuous devices such as smart dolls have been compromised due to a lack of encryption, jeopardizing conversations with children. Equally disconcerting, unsecured online storage of smart lock credentials has opened the door to anyone gaining access to homes. These incidents underscore the key issues plaguing IoT security.
Let's discuss the measures taken by the companies to protect the user interest and privacy. In numerous cases, IoT companies have exhibited concerning negligence in addressing security vulnerabilities promptly. Orvibo, for instance, took over 2 weeks to respond researchers before securing their data. Similarly, Anthropic PBC's cloud exposed data without passwords initially, and a smart thermostat company failed to address the issue of storing Wi-Fi credentials online. Even when vulnerabilities are pointed out, some companies have been unresponsive. Researchers identified vulnerabilities in a child's smart doll, but the company did not rectify them. Moreover, smart lock credentials have been publicly available in plain text for over a year. These incidents emphasize that many companies are not prioritizing security, leaving default configurations and exposed data online despite vulnerability reports. Strengthened regulations and oversight may be necessary to incentivize prompt privacy and issue resolution. Now let's talk about ensuring data security from server to sensor. Protecting privacy in the context of IoT sensors is of paramount importance, and there are several strategies to achieve this. Opting for devices equipped with local processing capabilities allows for the analysis and anonymization of data before it's transmitted, reducing the risk of sensitive information exposure. Ensure encryption in transit and at rest to prevent snooping or censored streams and while stored on servers or devices. Segregating IoT network traffic from other devices using separate gateways or VPNs helps maintaining data isolation and security. Regularly update devices and be selective about what data is shared from individual sensors. Configure sensors to only collect the minimum necessary data through consent controls. Research privacy policies and third-party users, avoiding devices and platforms with overly broad practices. These measures collectively empower users to safeguard their privacy in the era of IoT. Now let's talk about the implications of unavoidable tracking. The implications of the unavoidable tracking through IoT sensors vary significantly across different demographic groups. For adults, the financial impact is a central concern, as tracking can influence insurance premiums, credit scores, and expose them to a relentless targeted marketing, potentially impacting their financial well-being and decision making. In the case of elderly, IoT tracking can offer benefits like health monitoring and support for independent living. However, it also raises concerns about data security and the potential for elders' abuse, making it a complex issue to balance. Low income individuals face a disproportionate financial impact due to tracking, often encountering high insurance premiums and less favorable financial terms. Conversely, middle class individuals may find themselves subjected to extensive targeted marketing, potentially leading them to spending and financial stress. High income individuals, on the other hand, generally are more financially secure, may prioritize data security concerns given the potential for identity theft and financial fraud. In the marginalized communities, IoT tracking can perpetuate discrimination and inequality, affecting housing, employment opportunities, and access to essential services. To curb these potential harm, strong privacy regulations and data protection laws are needed to ensure the responsible and ethical use of IoT sensor tracking. In conclusion, IoT sensors offer undeniable convenience and efficiency in our daily lives. Yet, we must remain vigilant regarding the privacy risks they pose. To safeguard our personal information, Advocating for robust privacy regulations is crucial. Additionally, we should exercise caution in selecting and using IoT devices. Achieving a balance between harnessing power and the advantages of IoT sensors and preserving our fundamental right to privacy is an ongoing imperative. Thank you.